pleasure to be able to speak about two of my favorite topics, mountains and water. So what I would like to do is to ask a big question, and that is, can mountains deliver enough water to meet our future needs? And in doing so, what I'd like to do is explore the role of climate change, looking at future demand for water, asking the question whether we have that much water, and then looking at food, energy, livelihoods, and environment, some of the key topics of this meeting. So, of course, to go back and take a global point of view of mountains, mountains occupy about 24% of the land surface, about 12% of the world's population lives in global mountain systems. About 10% of the world's population depends directly on the livelihoods, but 40% of the world's population depends indirectly on many of the mountain water supplies, like water, like timber. So it's basically 10% of the world's population delivering services for another 40% of the world's. Mountains are truly a global resource. So the question, one of the first questions when thinking about water, looking to the future, is to ask how much more water will we need for food, for drinking, for energy, and the environment. And a first question on that is really looking at ourselves. How much water do each one of us as individuals consume? And oftentimes we think about drinking water. We drink about 2 to 5 liters of water a day. We think about household use. A bucket might be about 20 liters, but many people in places on Earth use up to 20,000 liters, especially if they have lawns to water. But if we think about how much water is needed to produce a kilogram of rice, say between 500 and 3,000 liters of water, that's a half ton to 3 tons of water per kilogram of rice. If we eat, I know it's not a meat-eating country, but if we ate some chicken, it would be the same story. 5,000 to 20,000 liters of water, up to 20 tons of water. Then if we put it all together and say how much water do we consume every day? If you're a vegetarian, that might be about 2,000 liters. But if you're a heavy meat eater, then it's about 5,000 liters, depending on what you eat and how much is consumed. The reason this is important is because with urbanization and wealth, people tend to eat a lot more meat and water-rich diets. And the other important part of this is food. The need for future food really is dominating the future water supply equation. But if we're also thinking about water, we have to recognize that already on Earth we're suffering. Right? There's land degradation in many parts of the world that limits agricultural productivity. We say that many river basins are closed. In other words, we've used almost every last drop so that very little flows out into the sea. And coming from the Himalayas, the Yellow River in China, the Indus, the Amu Darya, are all examples of closed river basins. It's hard to do another irrigation system in those river basins. And we see groundwater overdraft in the plains in many regions. India, in particular, has this issue. But another thing, and what strikes me is when sitting in Nepal, I don't know if it's true yet in Sikkim, but we get a lot of fish, right? Well, where does that fish come from? It comes from aquaculture, which is another user of fresh water systems, as well as natural fisheries, of course. And one of the things about livestock is there's limits to additional grazing land, meaning that we have to grow more, say, maize to feed the animal that takes a lot more water. So if we think about that, humans are already setting an ecological limit on Earth. So this is a picture of groundwater, and people I'm sure have heard about in India, also the recharge water from rain, but also mountain water in the Punjab and South India. Also in the upper right-hand corner on the Yellow River Basin, also water coming from the Himalayas. it's like a bank overdraft. We're going into debt already with our water resources. So if we look at a map of water scarcity, we've defined two different kinds of water scarcity. The first in the red areas is a kind where people have basically, in the river systems, used up all the water. They've put dams in, put groundwater systems in for drinking, for irrigation, so that if you wanted to do something else, there'll be less water flowing out to the sea and put a great stress on the environment. But there's another kind of scarcity that's quite important because it exists in mountain regions. In a lot of our mountains, there is a lot of water, right? There's water in rivers. The Tista River is huge, right? There's a lot of rainfall, a lot of snow in mountain areas. But if you ask a lot of people living in mountains, they'd say it's water scarce here. It's hard to get water up on the hill slopes in the region. So if I look from an individual perspective, from the perspective of a woman trying to get water, having to walk several kilometers to get it, there's water scarcity here in the mountains, but of a much different source. And that's very much in the blue area. So if we look at the regions from the Himalaya, we see that we have both kinds of water scarcity. This part is what we call economic water scarcity, where we just don't have to put in the finances, the infrastructure, the community development to deliver that much water. So basically the picture in today, in the year 2012, is that we're already in trouble with our water resources. If we're looking into the future, though, how much water will we need? There are several drivers. One, we went into this, population growth is one, but diet, population plus that change in diet makes a huge difference. And so even though population is projected to grow from 7 to 9 billion people, people say we need 70% more food because of the change in diet. The second is many people are moving to cities. And there's a much greater need for drinking water for cities. Not only that, urban people tend their diets more than rural people. And agriculture is continuing to grow and continuing to expand and use more water. We know we need water for hydropower, and in fact, hydropower and biofuels compete for water if we're looking into the future. And then on top of all that, we have climate change, shifting the patterns of water availability. So the equation is something like this. We'll have more people that need more calories, who tend to eat more fish and more meat and more milk, and meeting more grain production, such that we need to grow 70 to 100% more food by 2050. And if we look at today, how much water is used, this is in terms of crop transpiration and irrigation withdrawals. It's about 6,800 cubic kilometers out of the 100,000 cubic kilometers of rainfall. If we look to 2050, what does that mean for water needs? And we don't have any productivity gains. It could mean that we almost have to double the supply going into evapotranspiration, and I don't see how that will happen. So we're not in a good situation with our water supplies today. This is just the same kind of calculation for South Asia. The red is the future, again, almost double Southeast Asia, very, very much the same. And that makes sense with all the economic growth we see in South Asia. Energy. We're driving up the Tista River. It was quite remarkable. I think there were 3 new power plants going in. Wow. And then even we stopped and saw a hydro plant on the rivers. I guess the one thing about energy is it's not a consumptive use of water so much. It goes through but it is a big user of water, and there's so much more demand in the future for water supply. Certainly Bhutan, 100% of Bhutan's energy comes from hydropower. There's big potential, some of it installed. China, we don't quite know the figure, but still we know they rely a lot on hydropower. India, again, a lot of potential, and that's what we saw, I saw yesterday, was the demand, huge demand for hydropower increases.